So first of all, during this time that, first of all, I want to thank the organizer for inviting me to this event. I'm a citrus researcher, so even if I changed during my professional career in other crops, but I'm very pleased because after the trend, the projections in climate and market, and now we have to deal with the diseases, so which is another big challenge for citrus culture. I need for the, yeah, okay. Well, I can start about HLB because it's already here, the slide. So Wanglongbing, or citrus greening, which is now becoming really a big problem. Not now, I should say, in other countries since a long time, but it's becoming a serious threat for the Mediterranean region. That's why we are discussing in Morocco today, because it could be one of the serious threats also for the Moroccan citrus industry. And so I think that HLB, for this reason, is also considered so important, because there are no control measures, and so it's a very okay, that's it. Thank you. Okay. Yeah, so I just changed it to, yes, just this was a slide to present my organization. I think some of you knows Siam Bari is my institute, and we do already education, research, and cooperation for many years already in, wait a minute, sorry. Oh, there is something wrong. I don't know. Probably I have to go like this. This doesn't work. Okay, thank you. And so we deal with phytosanitary plant health problems since many years, and we try to develop also innovative methods and tools for early pest detection and sustainable control. So as I was saying, HLB is already, is becoming a serious threat. This disease is induced by a phloem-restricted pathogenic bacteria, and we have 3 species: the Asiaticus, the Africanus, the Americanus, Candidatus liberibacter. And in reality, it affects all types of citrus, especially sweet orange and mandarin, which are the most important, and is, as I say, quarantine pest in Europe, but even is considered for its serious severity a potential bioterrorism agent under the Agricultural Bioterrorism Protection Act. So just to give you the importance of this pathogen, so no effective control measures are available except the eradication of infected trees and vector control. So not much to do, and that's why citrus pathologists say that if HLB enters an area, citrus can no longer be grown. So it's another big problem, and the symptoms are very important, because one of the first approaches is to find the disease through visual observations. But as you can see, yellow shoots, leaf blotch mottle are very also typical of other problems like zinc or manganese deficiency, so are not really so specific. For example, the dwarfing of the trees is also induced by other pathogens, and the lopsided fruits with the color inversion, aborted seeds, are also induced by, for example, Spiroplasma C3 and the stubborn disease. So it's not easy to identify HLB as HLB at the first. So symptoms are particularly severe in the nursery replants or pruned branches, and this is very important. We say that already everything comes from China, So even this problem comes from China as an origin. Before 2004, let's put this as a sort of a deadline. It was mainly encountered in the Asian, Southeast Asian, Arabian Peninsula, and Africa. But in 2004 was first reported in Brazil, in 2005 in Florida. So as was already mentioned in the previous presentation. And so this is very important because in these countries, of course, in all, especially in Asian, but also in the American continent, is persistently transmitted by the Aphorina citri, which is one of the major vectors of the Asiaticum liberibacter. And then in the African peninsula, in African continent, is mainly transmitted by Trios erythrae, which is the African citrus psyllid. And as you can see, the two psyllid have a different behavior. The Aphorina citris is a heat tolerant, and Trios erythrae is a heat sensitive. And also the Trios erythrae is inducing symptoms which may facilitate growers to identify the presence of the vector. And so what does it mean persistently transmitted? Means that the psyllid, one psyllid, can transmit for all the life cycle the pathogen. So this is make more difficult the control. And two additional new vectors have been identified in China and Bhutan, the Pseudopsila citrisuga and the Aphorina communis. So when we find the new areas, we may find also new vectors. But what is important to underline that worldwide, New Zealand, Australia, and the Mediterranean basin are apparently the world's only HLB-free citrus regions. So this is a very important issue to take into account because Australia is doing a lot of work to prevent this problem. And as all pathogen graft transmissible, is transmitted a long distance by infected propagating material. But as I say, the vectors have an important role in transmitting the pathogen in a specific area. I'm not going to stay longer on this because I know there are other presentations on HLB, so I go directly to the fact that this insect is infecting all the plants in an aggregated way. So we are going to expect to find, let's say, clustered of infected trees in the groves, at least 50 meters away. And it's very important also to take into account that the damage is, let's say, correlated to the number of infected insects that are feeding on the plant. So more is the inoculum, more difficulties is for the plant to face the infection. Detection, we have many methods apart the traditional ELISA and PCR, molecular and serological. We have, of course, the direct tissue blot immunoassay, which is also very effective because not only as a serological method, very easy, but also because printed membranes can be used in the molecular assay, which is also important for on-site detection tool. And we have the real-time lamp, which is a very easy molecular detection method and can be used also on site by not skilled personnel. And then we have the tissue print real-time PCR, which is also, of course, very important. But I want to underline that even if they are not commercially available yet, but there will be, we can make even easier for growers or for nursery, not only for plant protection services, to use the disc mid-vein or a disc of a printed membrane with the plant material to be used in the real time, which is a very easy diagnostic tool that relies on ICGene Plus, which is a a device for processing the samples, and you can see directly on this curve the presence or not of the pathogen. There is also another testing which is commercially available by ONGHIA, which relies on the combination of a real-time lamp and the use of the lateral flow, which is like the pregnancy test, in order to see if the results is positive or negative. But we have many possibilities to rely also from Japan, just on fluorescence, which make in the evidence the color of a negative, red, and positive and green without any machine. Or we have the detection kit of the traditional real-time lamp, which was developed in USA, was the first developed tool. So no problem about detection. Not only detection of plant material, but also detection of the pathogen in insects. So is very important as a first approach, as I say, the symptoms. So we have to first, let's say, monitoring the growth for symptoms, because those are very important for identify soon the problem. And so we have to, of course, scout the symptoms in the field, or by walking, or by tractor, or by platform, depending on the size of the trees. And this is one of the major activities that has been done, is still done and carried out in Brazil. And very skilled personnel are scouting by tractors. And of course, they are combining the scouting of symptoms, so the remove of the plants which are symptomatic, with vector monitoring and treating. But as you can see, that the mention of the groves and also the owners are not many, so they can really rely also on airplane for treatments, and they can do very, harmonized approach. The problem is in Florida, that was found in 2005, and the situation, as you can see, is completely different. The groves are fragmented, and as you can see, it's very difficult to adopt measures, on a large scale. But it was also noticed that the psyllids, the infected ones, were also moving in the country through the unprocessed fruits, and this was, facilitated this investigation by the use of a real-time lamp, because they were testing psyllids and they found they were already infected, and they were removing the psyllids through unprocessed fruits. So the first thing I think to rely is the early pathogen detection using very easy, user-friendly molecular tools. And of course, to collect vectors, you need traps. Can be sticky traps, or you can collect by aspirators and put in ethanol in tubes, or you can rely on smart traps, which are more effective also because they are collecting the insects not only in one day, but for a certain period, so which is more reliable for insect collection. And of course, you can testing the insects using the lamp, which is based on 3 steps: nucleic acid extraction, reaction preparation, and genetic amplification in 30 minutes. So this can be done easily in the nursery and in the field. And of course, we can combine to psyllid vector testing other tools. We have seen before the modeling, so even forecasting models can be used in the case of pathogen and vector in order to identify the best period for monitoring. And so be sure also to collect the insects so after they are feeding on plants, and so they are acquiring the pathogen. And of course, smart traps, if it's possible, and on-site detection tool like the real-time lamp. Here there is a nice scheme, let's say, of all possible action that can be applied, like say in an integrated pest management approach. And I cannot mention all, but I think we should take into account some of them, especially also as practices, let's say best practices to be applied in advance before the problem arrives. And so the first, of course, use of a certified propagating material, and that's it. And removal of disease tree, which we have already seen, but also the intercropping with the repellent plants. We have they found that the guava has a very important repellent action against the Diaphorina citri. So guava is also a productive plant, so it could be very interesting to start an intercropping with this plant, and also the application of products. Of course, when we deal with this problem, we don't have to think that plants should not be treated, because otherwise we cannot apply vector control, we cannot succeed. So this is very important. I will also go on a very important issue is also the use of psyllid parasitoids, again for the vector. And here we have two types of parasitoids. And also important is the nutritional application, because as we have seen, the deficiency is mainly due to, as a symptoms, to manganese, zinc, and magnesium. And so to, let's say, to make the plant more healthy means also, by this treatment, to have a plant that is able to defend against infection, because anyway, the plant usually is a defension system, but needs, of course, to be on a good health for that. And then, of course, the important also the irrigation, which improve the, of course, the healthiness of the plant, the good state of the plant. And so there are many actions, and we can, of course, try to start this management, and I think there will be also another presentation on this. It's very important to combine technology, but also a good management practices for preventive, to be ready, let's say, to the arrival of HLB. Here we have a situation, let's say, Mediterranean situation on possible risk of entrance of HLB, but mainly of the vectors, because probably infected trees are already in the Mediterranean. Probably, I should say most probably, because we have, of course, imported, even ornamentals can carry asymptomatically the pathogen. But what is important is that the vectors are not yet present, and so the vectors can play the important role for disseminating the pathogen, because the pathogen cannot move without vectors. So the vector is the most important actor in disseminating the pathogen. And we see that here from Diaphorina city, from the Asian continent, is already arrived, as already mentioned, in Israel and Cyprus. Here we have the Triosa erythrae that arrived in Madeira Island, North Portugal, and Spain. So the Mediterranean has already the vectors, so the pathogen is already there. So now it's just a matter of time to see the symptoms. And this is the true risk. So the Mediterranean, we have seen already that for fresh fruit is a very important region. Florida and Brazil are struggling against this pathogen, and so we have to take actions. And of course, here I just summarized the use of certified propagating material combined with the early pathogen surveillance program, eradication of infected plant, and vector control, which are the major basic, let's say, action to be taken. But in prevention, we can also rely on technologies, because We need, anyway, technologies to make a good data collection, especially if we are monitoring. And for example, we developed for Xylella fastidiosa, but then we extended to the other pathogen, including the agents of HLB, we call APEST, which means that we can collect the data for geolocalization, acquisition, mapping, storage, and for transmission of data collection to the Plant Protection Service. And so we have this function, sample, map, find, ascend. And we can, the people that are monitoring can, at the end, issue a label reporting all the information. But what is also important, that they can take the talk and listen function, which means that if you don't see the screen of your smartphone for using this application, you can also talk and listen. Then, of course, these are some screen of what you can collect as information for plant sampling, for vector sampling, but also for sampling a site without funding anything. Then we have a remote sensing approach. Remote sensing application can be very useful for plant host mapping and also for identify some pest outbreak once they've been found. So we can identify the problem, understand the problem evolution, and support the decision for treatment, for measures, and also assess the efficacy of these measures after we have applied. But in reality, for this type of pathogens, when we see the symptoms, it's too late. So it means that there are not many things that you can do anymore. So we have to really have a challenge to early detect the pathogen before symptoms occur. And this is still a very critical issue by applying not only remote sensing, but all other also technologies. Usually, there are programs that are no free satellite, are very costing, and they produce a very important data, hyperspectral or multispectral data, but they require a very skilled person to interpret this data. And so usually Plant Protection Service are not using this type of technology. And there are also programs like Copernicus, which provides freely available data, but they are, even if they are free, they are not high-resolution data, so are not really very good for pests, for identifying the pathogen. Anyway, remote sensing is very effective in, for example, this is a combination of remote sensing and GIS, is an algorithm that allows to facilitate the monitoring of citrus plants by processing the multispectral imagery with this algorithm for automatic tree counting. So we can let's say, verify the number of plants during monitoring of a grove. We can also try to in advance plan the sampling scheme to be adopted, and also to combine the data for the results of the infection by laboratory testing, and evaluate also the spatial distribution of the infection. There are already some tools, even if they are not really so precise, but can really help in monitoring, like the vision sensor that can, let's say, identify, let's say, suspected leaves showing symptoms resembling those of HLB, and devices for also multispectral reflectance images in order always to identify trees which could be suspected also to be infected. But also there are prediction models like we have seen for climate or others. Our models can be helpful also to, let's say, help the monitoring program. we cannot say that are, can find the problem, or just to help, especially the monitoring program in sampling. So there are some, let's say, satellite data which are, as I say, very interesting to use, but cannot be so performing. Proximal sensing tool, automatic algorithm for sampling, but in reality, we have to do a little bit, we have to go a little bit further. As I say, we have to try to identify the problem when symptoms are not yet developed. This is the challenge, still at the research level, and has been applied for Xylella fastidiosa on olive trees. But the challenge is to try to, let's say, know in advance the package of spectral signature here related to the problem, so can be, in this case, HLB, and provide the inspectors with this sensor in order to monitor and find for sure in this case, HLB. We have done, as I say, for Xylella, and it's based on that we call the spectronomic approach. What does it mean? That we combine the spectral signal of these metabolites, which are correlated to the infection. So when the plant is injected by the vector with the HLB, there is already a defense system that starts, and the plants produce metabolites. These metabolites have a signal, spectral signal, and this spectral signal...
Anna,
yeah?
if you have just 3 minutes, okay?
Okay, I go. So these spectral signals gives us what? The possibility to see, to see in advance the problem by a sensor. Okay, I go further. So what is now necessary to apply this is to develop a sensor that can have use this package of wavelengths which are pest specific in order to identify the problem on a larger scale, and needs, of course, study, research. And this is the critical issue. So the combination of more technologies are very important, as I said. So apart the planning maps, apart remote sensing, applications and models for field data collection, laboratory data, and then a phytosanitary service can rely on all the information for a single trees that has been monitored. So until resistant citrus varieties are developed, this will take some time. So we need to rely on prevention. And just to summarize, the vector approach of testing vectors, monitoring vectors for assessing the presence of the pathogen in advance is essential. The disease identification and forecasting by using also technologies like remote sensing, prediction map, ground sensor is also important. But again, the growers can start to apply best practices, which part can be very useful for the grove, for the citrus groves, but they are also useful to prevent and to prepare the plants to be infected and to be able to react to the infection by the agents of HLB. And I want to just focus the attention on the part the monitor and control of psyllids, but also the intercropping with some plants which can play an important role against the psyllid. Thank you, and just to inform you that there is a Congress in Bari, and is on Mediterranean Phytopathological Union, and there is also a session on HLB. Thank you.
Thank you, Dr. Anna Maria.